Today we have a special guest, Jake Engle, with us, and he will be talking about product line engineering and the exciting ways that you can manage a product line in Cameo Systems Modeler. So with that said, I'll pass it over to you, Jake, and please tell us a little bit about how we can implement this type of plugin extension that Cameo has to offer.
Yes, good morning and thank you, Brian. I'll start off just by, my name is Jake Engle, work at STC as a principal model-based systems engineer, and here's some contact information. And we're going to dive in today on the new model-based product line engineering plugin that Cameo offers, and it was released with the Service Pack 19.4, so it's been out for a couple years now, but I think still a lot of folks in industry are learning about it and leveraging it. So let's get a little deep dive into, feature-based product line engineering and how we're using Cameo to do that. So some definitions, just to start it off, is we have PLE, product line engineering, and I don't want to, kind of steer the definition too much, but it's just a way to engineer a portfolio of related products in an efficient manner, taking advantage of product similarities while managing their differences. Okay, so you'll start to see that we have several key parts of a product line engineering ecosystem, and we're going to kind of dive off into those with these next definitions. So we have shared assets, which are just artifacts that support the creation, design, implementation, deployment, and operation of products. So your shared asset supersets are essentially your architectural models. And then the superset right below it is a shared asset used in the product line that takes form of a superset. So for instance, a good example would be all of the requirements. So if you're defining a product line, there could be multiple different variants of a product. And all of the requirements that are associated with those different variants under a product line would be captured in a superset. And then feature, so not to confuse a lot of folks with the agile term feature, but a feature in this term is a distinguishing characteristic that describes how the members of a product line differ from each other. Then our feature catalog, and that's simply just a list of all of our features. Our bill of features are the specific features that are associated to a product or a variant of that product line. PLE factory configurator. So this is the automated software tool that applies a bill of features to all the shared assets. So what it's going to do is it's going to evaluate all of our existence variation points, which is a type of constraint, and then it'll pull the applicable or defined configurations that are specific to that product. So that's the PLE factory configurator. The variation point, specifically, what this is going to look like in Cameos is our existence variation point library. So whenever you choose something while configuring a product, with this variation point that you create, it's going to pick that from your architectural model and say, hey, this is applied on this configuration. And then our product asset instances are simply just the output. They're all your variance models. So you'll notice, and we'll walk through this process to get the instances, but you will perform a model transformation once you are done defining your configuration for a specific product, and that's going to give you your product asset instance. And then that's going to be a branched project off of your trunk, which exists in Teamwork Cloud. So what that kind of looks like, this is actually the solution from the PLE and Cozy Primer, which is out free on the internet. Here you can see some of the portions that we described, our feature catalog, just our list of features, bill of features, those things that are specific to the product, shared asset supersets. So this is going to be all of our architectural pieces, requirements, structure, behavior, so on. Factory configurator is your existence variation point library that we're going to build. And then your product asset instances are all of your variant models. And what that looks like within the entire ecosystem, wherever your Cameo, Teamwork Cloud, Collaborator, all of that exists on your organization's server for these tools. This is how you would set it up. So Teamwork Cloud encompasses everything. So everything is saved on Teamwork Cloud. And then you have your product line trunk model outlined in this black box right here. All of these are enforced by some sort of governance too, and that's just that's something that we do specifically at STC and recommend throughout industry. But here you can see under the black box we have, this is going to be one model, and it's going to encompass all of these basically packages. So this is going to be a factory configurator package. This is your feature catalogs, all your list of features, your existence variation point constraint library. And here you can see that those are applied to your architecture and your requirements in order to generate these asset instances. So factory configurator, you kind of see how I've set the relationship between the two also, because there's going to be associated diagrams with these in these packages. So for instance, this factory configurator is actually an instance table, and the classifier you set to is the root feature group, which is, we'll kind of dive off into more of those terms whenever we get into the model. And then you can see your existence variation point has a feature impact back to your feature catalog. And then whenever you define something in the configurator, it's saying, hey, I'm choosing these features, but this right here, these constraints tie back to it, and they're applied to these portions of our architecture. And that's what's going to give you your variance. But I think that's good enough, and we're going to kind of dive off into the model.
Yeah, that's great. Thanks for that background.
Yeah. So today we're going to focus on the automotive industry, because it's very easy to do product line engineering in the automotive industry, and they've been implementing it for a long time. Specifically, we're going to look at a GMC Sierra 1500, because I know that truck very well because I happen to have it. So it's easy for me to define. So, some of the first things that we're going to do is we're going to create those packages that we were talking about for that exist within your ecosystem. So you're going to have your feature model. You're going to have your requirements model. And you're going to have your system model, if I could type. You're going to have your configuration model, and also one more, your existence variation point library. And these 5 things are going to allow you to do everything that you need to do. And I forgot to mention, before you do any of this, you have to not only have the MBPLE plugin installed from your resource plugin manager, and it's a no-cost plugin, so you can get it from No Magic. You have to install it, and then you have to do a use project to the MBPLE profile. And I already set that up. Here you can see it's under my use project. But if we get a file, use local project, I'm going to choose one for my system, choose where it is, and all of these exist for the most part wherever you install Cameo. So ours just happens to be under the C drive, program files, systems modeler. Here's the installation directory for Cameo, systems modeler version 2021X, and then profiles right here. And you can see the MBPLE, and you'll just press open. It'll finish that for you. And that's going to allow you to leverage some of the specific stereotypes that the MBPLE profile offers.
Gotcha. That's great.
Yeah. I should have started with that. Sorry.
No, that's fine. Good to know that. Thanks for adding that in.
Yep, definitely. So we'll start off with the feature model. We're going to create a diagram, and you can create a SysML block diagram, or you can create a UML class diagram. I will say that the UML class diagram is a little bit easier to use because all of your options exist within the palette tree, because the specific stereotypes for PLE are actually applied to the class rather than the block element. So I tend to use the UML block diagram, or class diagram, excuse me.
Gotcha. Okay.
And here you can see kind of what I'm talking about. We have these options for like root feature group, and then other ones are going to be feature group, you have class and enumeration. So
Okay.
at the top level, the highest, tier, we're going to do our GMC Sierra 1500 because that is our product line that we're focused on. And you can see it's typed by the RFG, the root feature group. And then let's say we're going to have a couple options for, let's just do engine, transmission, and then some interior options. And I'm going to do those three and focus on those three because there's a distinguishing factor on what you're going to use in terms of enumeration versus feature group. And that distinguishing factor is if you are going to be choosing one specific feature from a list of features, then I would recommend you use an enumeration as your classifier. But if you're going to use if you're going to choose multiple things within one feature group, such as interior options like navigation, air conditioned seats, so on and so forth, use the feature group, and then you're going to type those features by a Boolean expression because it's going to allow you to turn all of those on and off with that true false.
That's great.
Yeah. So for the feature group, what I mentioned, we're going to do the interior group, and we're going to do the engine and transmission as a enumeration because you only have one engine and one transmission. Also going to add another portion in here for the chassis because I want to, leveraging PLE, you remember it's maintaining those similarities, but managing the differences. And the similarity across all of these, no matter what it is going to be a chassis, right? For instance.
Right.
So basically what we're saying is all three of these, and there's going to be one other, are going to be a feature of this GMC Sierra 1500. So in order to do that, we're going to add a feature. First one's going to be interior. Engine. Transmission. Then I'm going to do chassis. Okay, so our interior is going to be typed by our interior feature group. And you can see that it's typed by the interior. And once you drag this relationship off, you'll know that you've done it correctly because it has this little F, which stands for feature.
Okay.
And you'll take note of that because if you were to set this up a different way and you were just creating a generic block diagram and you didn't notice that this F was included on this relationship when you drag and drop it off, your instance table won't work. So your configuration will say, I don't recognize this group as a feature without making sure that you create the feature itself and then typing it by whatever block it's supposed to be typed by.
Okay, gotcha.
So this one's going to be engine, transmission, and then for this chassis, I'm just going to do a simple Boolean. Okay. So engine, drag that guy off. It's good. Transmission, drag that guy off. All right. So for our engine options, we're going to do just a couple because I don't want to take up too much time on this demo. We're going to do 5.3 liter V8. And let's just do a transmission. We're going to do a 8-speed and a auto 10-speed. Some of our interior options we are going to do, make sure we list them as a feature. Well, hold on, make sure I did that right. Make sure whenever you're adding to your feature group, you're doing the feature and not a property. We're going to do navigation. And here you can see that it typed it by a feature. We're going to do AC seats, heated seats, if I can click on it. What else? Any other interior options that you have on your car, Brian, that I'm not covering potentially, just to help the audience?
Let's see, heated seats, navigation, AC, backup camera, maybe something like that.
Backup. Yeah, I know some of the new ones even have like heated steering wheels.
Sure, yeah.
All right, and all of these are going to be typed by a Boolean expression. Ooh. Sorry for the background noise. There's trash guys are coming today.
It's not, we can't even hear it.
Good. All right, so what we have done is laid out our feature model. Very simple interior transmission and engine. Okay, and for these, for instance, on that bill of features, the reason we call it a bill of features too is because we're gonna assume that there's some sort of cost associated with them. So when you define your specific trim packages for the GMC Sierra 1500, you could actually do a parametric diagram to see the total cost of all of your options that you're choosing. So in order to do that, you can just do a simple value property, right? So nothing crazy.
Gotcha. All right.
All right. And then we're going to let's do the requirements model because it shouldn't take, excuse me, do a table, a lot easier. So we're going to have, basically a requirement for each one of our features. And we can, I should have done some of this already before, Brian. I'm sorry, but I wanted to show everybody how we do it, start to finish.
No. Yeah, it's good to see the process.
Yeah. So number one, we'll start with 5.3. GMC, we'll just do a simple requirement. Shall include, which that's probably not the best wording, but that's okay. A 5. We're going to reuse this right here. This is going to be Duramax Eco Diesel engine. A 8-speed transmission. Speed transmission. We're going to include a chassis, and then start our interior features. Navigation, seats, heated seats, backup camera, and heated steering wheel. All right, and then we'll just delete this guy. So this one is named heated seats. The Duramax. All right, so just a simple requirements diagram or a table, excuse me. That's going to be all of them so far. Nothing crazy.
Great.
And then let's go into the existence variation point library, because this is the key thing that kind of the back end that ties everything together. So for this, we're going to create a generic table so we can query all of our existence variation point our existence variation points. And in order to do this, we are going to create an element, create a constraint. And then what I recommend is actually naming your constraint by the feature so it's easy to map to.
Okay.
So for instance, we have the 5.3 liter V8 is one of them. And then this right here is going to be, we're going to query the existence variation points, and they're all going to exist under our package. It makes it a little bit easier. And then we have to actually stereotype this constraint by an existence variation.
That's interesting.
Yep, and that's what that's saying is basically when you pick this, it exists. That's all it is. That's all it means.
Okay.
So, yeah, and why it's not showing up in here. There we go. All right, and then in order to create your relationship back to your feature model, because that's where we're defining this right now, right? And we're doing a feature impact relationship back to our feature catalog, which has already been defined. So we're going to come in here, we're going to go to feature impacts and make sure you do it on this left-hand side. For some reason, if you do it in one of these attribute fields, it doesn't work. You actually have to do it on this side, which I don't know why. But anyways, we're going to add, we're going to do, we're going to point back to basically this feature and where it exists within the model. Now, because this is the feature itself is typed by an enumeration group, so they're enumeration literals, we're actually going to point towards the enumeration group itself, which is going to be the engine for this standpoint, or for this case, right? So we're going to test. So what we're going to do is we're saying, hey, we're pointing back towards this, but we're going to test for the specific engine itself.
Okay, gotcha.
Yeah. And that's just for your enumerations. If it's a feature that's typed by a Boolean expression, you just do your feature impact relationship to that Boolean feature. So what I'm going to do is kind of create these quickly. Why can't that's why. So we're going to have Duramax. We're going to have speed, and then interior. About chassis. Interior option. Have backup camera. Okay. All of these are now going to turn into variation points. Makes it a little bit easier. Here you can see they're all populated now, and then we will do our feature impacts, add 3 dots. This is a transmission. Okay, and we're testing for specifically the automatic 8-speed. That's the name of the constraint.
Okay.
Feature impact, another transmission, testing for 10-speed. AC seats, so this is part of our interior. So this is a Boolean expression, so we're just testing for AC seats. That's the one difference. So you don't have to do a test for.
Gotcha.
Just doing a feature impact.
Okay.
Add backup camera. do another one. Chassis. This is an engine, so this one's got to be typed by the engine enumeration group. And then test for Duramax. Heated seats. It's interior. So it's a cooling. We got heated seats. Steering wheel. Heated steering wheel. And last but not least is nav. Navigation. All right. We've built up our existence variation point library, and I want to see and kind of check myself to make sure that I have all of the relationships defined. So on our columns, we're going to populate the feature impacts relationship just to say, hey, I point back to everything. And then eventually we'll also have another one for this constrained element, because that's what, I mean, once we start applying this to requirements, these constraints to requirements and these constraints to different pieces of our architecture, you'll see that this table is going to get very large potentially.
Okay.
So existence variation point library done, feature model done, requirements model done. Let's do a quick system model. Here, I just want to do, we're just going to do a block diagram. So block definition diagram, we're going to have a block for the GMC. That's our context. I mean, I won't do the stereotypes right now. It's not too big of a deal. I'll start off with engines. So 5.3 liter V8. Duramax. 2 transmissions is 8-speed transmission and 10-speed transmission. And yeah, we'll do interior too because we've been defining it. So we have navigation. We have heated seats. Backup camera. Heated steering wheel. All right, I'm going to create 2 different IBDs for this guy. One's going to be under the hood of the truck, so basically your engine and your transmission.
Okay.
So under the hood, we're going to just lay out all of our engines on the left-hand side, transmissions on the right. We'll just say that this guy can only have this one, and this one can only have this one. And then we'll have another IBD and call it, interior. Not right now. Okay. And it's going to have those 5 things. All right, leave it pretty simple. So we got our under the hood and we've got interior IBDs for the GMC Sierra. And that's our system model. You can do behavior as well, but I think for proof of concept, it's fine with just this.
Okay.
All right, so next step is we are going to actually apply these constraints to all of the architectural elements. So for instance, this 5.3 liter V8 goes to that guy. I wish I could do it that way, but I guess I have to do it this way. So we're going to apply the 5.3 liter V8 constraint on that 5.3 liter V8 requirement. I think I can do it this way too. 8-speed. 8-speed. I don't know if that worked or not. Let's look. Okay, it works that way. That's weird, but I can't do it from containment tree side.
Okay.
10 speed goes to 10 speed. Heated seat or AC seats goes to AC seats. Backup camera goes to backup camera. Chassis goes to chassis. Duramax to Duramax. Heated seats, heated steering wheel heated, and navigation goes to nav. And I know nothing's showing up, but it is working. And another way you can do this, Brian, the correct way to technically do it is come into the specification of each one of these guys, whatever elements you're going to apply those constraints to, and then just go to the constraints portion or that attribute specifically and apply it from here.
Okay.
Technical correct way, like that. And then you can see it's applied. But
Okay, gotcha.
this one, 8 speed. Constraints apply. 10 speed. This one is 8. Backup camera. Duramax. Heated seats. Steering wheel. And navigation. All right. So we have now applied all of our constraints to our architectural elements. And you can see that these right here have this little blue V right here. That's kind of hard to see. And I know we can zoom in on that, but that means that there's an existence variation point
Okay.
on these elements. That's specific to the PLE plugin.
Okay.
And so is the this root feature group and feature group. That's specific to the PLE plugin as well.
Gotcha.
The stereotypes.
Gotcha.
All right, so we have defined our system from a structural standpoint. We've defined our requirements. We've defined our feature catalog, and we've built our existence variation point library. And now it's time to actually go in and configure our trim packages for this specific truck. So to do that, we're going to create instance tables. So this one's going to be, we're going to name it the same truck 100 trim packages. Okay. And we are going to drag and drop the root feature group as the classifier. So what this does is this, you can see it populates all of the options you have. And if you're missing a few, it's only displaying 3 of our 4. Come into the columns and make sure you have all of them clicked. So in order to define a configuration, we're going to come in here, create with parts. And this first one's going to be the Denali. This is like the top of the line trim package for GMC.
Okay.
Here you can see that the interior one actually points to another instance. That's what that little element that icon is. So that means that it's actually going to point to a lower level instance table. So we actually want to have another instance table for our interior configurations. But here you can see that this is actually going to be a drop-down list. So when I double click on that and I choose my Duramax Eco Diesel, and for instance, the 10-speed transmission, and then we have to have a chassis.
Okay.
So that becomes true. But the interior portion is going to have a separate instance table. And we're going to name this interior. Okay. And we are going to create the classifier as the interior feature group. And we're going to create our parts with it. And we're going to name it the same thing as our trim package because we're defining the trim package for the Denali right now. This is just specific to the interior of the Denali. So we'll say it has all the options because, again, it's the top of the line. So just double click and make sure that's turned to true. And all of these are going to be true.
Okay.
Okay. And then on the highest level one, where the classifier is equal to the root feature group, come into your interior configurations, double click on it, click the three dots, and then under your configuration model, which everything exists, you can see Denali, and then it's typed by our interior enumeration feature group. So make sure you click that one.
Okay.
So we can see Denali, and then it has the Denali interior because we just defined that. So we're going to create just a couple more. We're going to do the SLT, which is like the next level down, and then we're going to do a work truck.
Right.
We're going to do something specific to. We're going to call this development truck because I want to show something. So dev truck. All right, so this one's the SLT is gonna have the 5.3 liter V8 with the auto 8-speed, and it's got to have a chassis. And then under our interior, we're going to define it, and it's going to have just a couple things. Conflict with existing specification SLT. Okay, we'll call it SLT interior. That's weird because it didn't do it for Denali.
Huh.
But that's fine. Navigation, it'll have that. We'll just say it doesn't have AC seats, so that's false, but it has heated seats. It has a camera. It doesn't have a heated steering wheel.
Okay.
All right, and then we will do the dev truck. The dev truck means, let me point this first to my SLT interior. That one's defined, dev truck. We're just going to say that it uses the SLT interior again. So that's kind of the nice part about PLE, right? You've already defined that configuration at a lower level, and we're just going to reuse it.
Okay.
And then on this one, I'm going to call it the dev truck because we're actually going to pick an engine and a transmission that are not compatible.
All right.
And what you're going to see on the what you're going to see in return, when the tool actually shows the red and green display. So we have defined 3 different trim packages for a GMC Sierra 1500.
Okay.
Now, what I want to do now, here's the cool part, right? This is where it takes all of that setting up in order to get to see the cool stuff. Well, I want to see the requirements that are applicable to the Denali trim package. Right. So come up here to your preview, click on your Denali instance, and here you can see it.
Okay, great.
Pretty neat. So we have our 10-speed transmission. So everything in green is included, right? And everything in red is not included. Okay. So very cool. And then now I want to see, well, what does under the hood look like? Well, I actually plugged these wrong. So I wanted to show this for development, but I can change this real quick. We're going to delete that. I actually wanted the Duramax to have the 10-speed transmission.
Oh, gotcha. Okay.
So we might cut that little portion out.
Just using connectors there?
Yeah, just very generic. And these it'll be nice though too, because you can actually do it by interfaces and stuff like that as well. Okay. You can apply a constraint to an interface. Done it in the past, Brian, like where we have different server configurations and they had different interfaces to other systems that they were supposed to, interface to. Okay. And I defined my feature catalog by the different servers or the different subsystems that they were going to interface to. Okay. And then basically you could just drag and drop those constraints that you build up that map to the feature model, right? And those feature models defined by the types of interfaces, however many, one config for A to A, another one for A to B, and so on and so forth.
Okay, yeah, that's really neat.
Yeah. So under the hood, this is what I meant to show. The Duramax to the 10-speed transmission.
Okay.
And obviously the 5.3 that's not a part of our trim package, interior. We got all the options, so everything's included.
Okay.
All right, now let's see. Let's see what the SLT has. Well, the SLT has the 8-speed transmission, the 5.3-liter V8, heated seats, backup camera, nav, and a chassis. Okay, so that's always included. What does that look like on my under the hood? Well, I got my 5.3 with my 8-speed transmission.
Okay, interesting.
Interior, you can see only the green's pulled.
Gotcha.
All right. So last but not least is the development truck that I did. And the reason I called it a development truck is because let's say you start to define a product that doesn't exist yet.
Sure.
Right. And then come to realize that you actually have some sort of engineering development work that needs to be done. And what that engineering development work is to do is basically get this engine compatible with this transmission, because that just does not exist yet.
Okay.
So that's kind of the nice part. You can easily see that, right? What type of work would need to be done.
Right.
So, and then also what's very neat is that let's say we want to see the similarities and differences amongst all of our trim packages in terms of requirements. So what we're going to do is we're going to select multiple variants. We're going to come in here. We're going to go to our configurator model. And I don't want to do the dev truck. I actually want to see my similarities and differences between my SLT and my Denali. Okay. And what it's going to do is basically compare those two.
Okay.
All right. So the similarities are in green. So what you're coming up with right here is basically a set of features that exist across both of these trim packages. The gray is what's unique about those specific trim packages.
Yeah, that makes sense.
Yeah. So it's a neat thing to see.
Where they overlap.
Exactly. Yep. And then what this will allow you to do also is, let's say you have like five or six different variants that you have defined off of your product line, and you notice that only one or two features or one or two pieces of your architecture are highlighted as a common component or a common capability. What you can do if you're selling products is you can start to mark those up as your premier features. You can be like, well, these are premier features, or they're always included, or whatever, whatever that may be. So.
Right. Okay. Awesome. So
we'll go back to no preview. That gets you back to this guy. And then last but not least is the model transformation. So, everything we've done has just been within this right here, this black box. But now, and we've defined our variants, but they only exist within here. So in order to create a branch model, this is all going to be done on Teamwork Cloud. Now, for today's demo, I'm not going to do it on Teamwork Cloud because I don't have the permissions, unfortunately, to create a branched model. But you would normally, we have our product line model that we're working off of, and that's all of this together that we have just gone through and defined. And then you would create a branch and you would name it potentially that trim package. Right. So just the Denali. I just want the Denali model. Okay. And then SLT for the blue guy, and then like work truck or the engineering development is going to be, this last one, this green guy.
Right. Okay.
So in order to do that, you do a model transformation. So tools, model transformation, and we're going to do specifically the variant realization. next, and I'm going to click the entire package for where everything exists in my model. And this select source and destination. This is just the scope of what you want to pull from, basically. Just defining that scope, and then next, and then you can see what configuration we want to do. We want to do specifically the Denali. So let's just look at the Denali stuff.
Okay.
And you don't have to check any of these boxes.
All right.
And then finish. And here you can see a lot of stuff just got ripped out, right? So now I am working on a variant model, and you know that because of this little red exclamation point, and you're working on a variant model.
Gotcha. Okay.
So, intent of this is new program comes in, for developing a new product, but it's got maybe 75% similarity with another product you've already developed. Having all of this already defined, right? I think you can start to see the power.
Yeah, that's incredible. That's awesome.
Yeah.
So, question for you. Say you get to this point and you have this variant model. Is it possible to still make changes in this branch and then merge them back in?
Yes. So once you create this branch and it's named, your Denali trim package or whatever your system of interest is, you are now just working on that branch. That becomes its own independent model. So you have those 75%, roughly, let's say for this case, 75% similarity in a model already captured. Okay. And then you're only going to work on that other 25% of that engineering development that needs to be done.
Okay.
So, and then yes,
once that is finished, you simply merge that back into the 150% model.
So once it's finished, it's a good point. So a lot of the times what we recommend, because now you're starting to get into product development life cycle and who all is touching the product itself in between sales, engineering, business development, so on and so forth. But let's say that you start to notice off of your products that you are defining that you start to get these new set of features that are common amongst several of your different products. Like this one feature, for instance, under the interior is now going to be heated rear seats. And we're starting to see that as a common feature listed no matter whatever product we're defining. That new feature, as it used to be, was part of that 25% engineering development, but now it's going to go to some sort of architecture review board and say, hey, we've started to see a lot of reuse of this feature. Maybe we should think about putting that in our feature catalog so we don't have to keep on doing engineering development work in order to, to satisfy that requirement that's being driven by a customer.
Right. Okay. And then it gets kicked back up to the higher level model at that point.
And then basically all it does is it gets kicked back up to this guy and say, hey, we have a new feature. It's been approved by our architecture review board, and it's that heated rear seats, right? So come in here, heated rear seats this time. It's going to be a Boolean expression, and we're going to walk through the same exact process that we've done. We're going to create a feature for it. We're going to create a requirement for it, some sort of, common shall include, something like that, potentially. We're going to create an existence variation point for it.
Okay.
And it'll have a part property too. Also, just to point real back to, I told you that some of this stuff was going to start to get defined. Yeah, grows. Yeah.
Awesome.
So
that's
neat.
Yeah, for the demo one, that's really interesting and a powerful feature that I don't think a lot of people know even exists for Cameo. So that's great to see some of the steps to getting through that process.
Sure, absolutely. I've been doing this for a couple of years now, and I've thoroughly enjoyed it. And there's all sorts of different applications for it. For instance, I'm working on with the customer right now on defining several different variants of a rocket. So if we can have this common library or model of this generic 150%, it's a common. It's kind of a word that we see a lot with PLE is this 150%. It's because the idea of it is that it's a superset, right? So it's
Right.
several different products and their architectural elements and the requirements that are captured in your model.
Sure. Yeah, that's incredible.
Yeah.
Awesome. Well, thank you very much, Jake, for walking us through that. And
Yeah.
we look forward to hearing more from you soon. And thanks everyone for listening.
Thank you.